This video is going to cover Trig Notes 5.3. We're going to talk about properties of logs. The main concept is understanding the properties that logs have so that we can learn to expand or condense these logs, which will be useful later on in the next chapter or the next section when we work at solving log equations. So the first thing I want to talk to you about is we talked about this a little bit in the last lesson, is using your calculator to help you find logs. The calculator is set up with base of 10. So the only things that you really can put into the calculator is log of like 5, for example, because it has that imaginary base of 10. If I ask you to put something like this, log base 3 of 9, in the calculator, you can't do that. But what you can do is use the change of base formula to use the calculator. So you would type it in the calculator like this: log of 9 divided by the log of 3. Because really what the log of 9 is the log base 10 of 9 and log base 10 of 3. So take a second to get out your calculator and type in log of 9 and divide it by the log of 3. Now when I do that, I end up with 2. Well, we should have already known that this answer was 2, because if I ask you to evaluate log base 3 of 9, I'm saying 3 raised to what power is going to give me 9? Well, 3 squared. So the change of base formula is going to be helpful to us when we can't figure these exponents out in our head, when we can't figure it out exponentially like this. So here's an example of it. If I write this in exponent form, I would say 2 raised to what power is going to give me 5? Well, I know it's going to be 2 something, because 2 raised to the second power is 4, but 2 raised to the third power is going to give me an 8. So I know it's got to be 2 point something. So to figure it out, I'm going to have to use the calculator. So in the calculator, I would take log of whatever I'm trying to take the log of, in this case 5, and divide it by log of 2. So log of 5 divided by log of 2, let's see, log of 5 divided by log of 2 in the calculator gives me 2.32. So 2.32 would be the exponent that I would have to raise 5 to. So in other words, 2.32 is the exponent on 2 that results in 5. Now it's not going to be exact because I've rounded that, but it's going to get me as close as I possibly can without using that exact number. So the change of base formula, you take the log of what the number is you're taking the log of, in this case log of 5, and you divide it by the log of the base. So the base always goes in the denominator. That's the big issue I see, is switching up the numbers here. That will change your answer. So this number goes in the numerator. This base goes in the denominator. So you have to keep that straight when you're using the change of base formula. And just to keep ourselves on the same page with log form and exponent form, remember that log form here, log of base a of 1 equals 0, is that my a is the base and my 0 is the exponent. Remember that the log is equal to the exponent. Over here, in exponent form here, a is the base and 0 is the exponent. Again, it's important that we keep that in mind, because now what we're going to be doing is we're going to be going back and forth from exponent world, as I'll call it, to log world. We're familiar with the properties in exponent world. For example, if you have x raised to the power a and you're timesing by x raised to the power b, we know that we add the exponents to get our answer. So for example, x squared times x to the third, you would end up with x to the sixth. So when you multiply, you actually add. Well, if we apply that same property, the product property, in log world, log of 5x, we're multiplying here, so I could rewrite that as writing it as the log of 5 plus the log of x. So when I see multiplication, I want to think addition. So we want to keep in mind that multiply and add go together here. If we think about it the opposite way, if I have two logs that I'm adding together, I can condense it into one log by writing it as a log that's being multiplied. Or I could go this way. If I have multiplication, I can expand it into two addition problems. And that's really what we're going to be doing in the examples, is we're going to be either expanding or condensing. If we think about the quotient property, if you have a x raised to a power and you're dividing it by x raised to a different power, so x to the third over maybe x to the fifth, we would say here that we would subtract the exponents. We would get x to the negative 2 when we did this. So we would subtract the exponents. Well, over here, if we're taking the log of something that we're dividing, in this case we're using division, we can expand it to write it as subtraction. Or we can condense these two logs that are being subtracted to write it as a log that's being divided. So we want to think of division and subtraction going together. And finally, the power property. If you have maybe x squared and you're raising it to a power, the rule here was you multiply the exponents. So this would equal x raised to the sixth power. So multiply when you're going from a power to a power. Well, the power property is a little bit different for logs. If I'm taking the log of something that's being raised to the power, what I can do with that power is I can write it as multiplication out in the front. So I'm still using multiplication, but I'm just using it a little bit differently. So you'll notice that they could write this as the 5, which was the exponent, times the log. So what we have to remember here is we write exponents as coefficients. Or we can write coefficients. I can go the other way by saying I could write this coefficient by putting it up here as the exponent with the x. I could write it as log of x to the fifth. So what we're going to do now is we're going to use these properties to either expand or condense logs. So let's first look at expanding logs. So as I look at this, I have one log of base 2 that I'm dividing. So right away I see division. So if I'm trying to expand it, I want to change division, write it like this, change division into subtraction. So here I could write this as the log base 2 of x minus the log base 2 of 17. So take one log and write it as two logs by writing it from division as subtraction. So from division, we'd write it as subtraction like this. So again, you're looking at the log and you're asking yourself, okay, right now it's being divided. I know that division and subtraction go together, so to expand it, I would change one log into two logs that I'm subtracting. Now over here, we have to get a little creative when we solve this. One of the things you need to remember is when you see a square root is a fractional exponent. So the first thing I'm going to do is I'm going to write this as log base 2 of 8 instead of the square root of 8. I'm going to raise it to the 1/2. So we have to recognize that square roots are the same as the 1/2 exponent. So something raised to the 1/2. In this case, it's 8 raised to the 1/2. So now that I have my problem written like this, the only way that I can expand this is I can write exponents as coefficients. So I'm going to change my exponent of 1/2 to write it as a coefficient out in the front. So it's going to be 1/2 times the log base 2 of 8. And that's as far as I can expand this one. I can't expand it into multiple logs. So sometimes we can't expand it into more than one log. And this would be an example here. This next example, the natural log of 3 times x squared divided by y. So right away I see division, I see multiplication, and I see an exponent. So let's first deal with the division and write it as subtraction. So I'm going to take the natural log of the numerator and subtract the natural log of the denominator. Okay, so I took the division and I separated it into subtraction. Now I've got multiplication here with this 3 times x squared. So now I'm going to change multiplication into addition. So this would become the natural log of 3 plus the natural log of x squared. So I've changed this from multiplication to addition. Just bring down the natural log of y. And the last thing that I notice is I have a exponent. So I can change the exponents to a coefficient. So the natural log of 3 would stay there. I can move this 2 to the front of the natural log of x, so it would be 2 natural log of x, and then minus the natural log of y. So this would be my final expanded form of the original problem. Now with my next problem, one thing that I want to keep in mind is sometimes when I see subtraction like this, I think I should write it as division. But when you see a binomial, you never break the binomials up. So let's write that note over here. Never break binomials apart. So I don't want to break this binomial apart. What I do notice right away is I have multiplication. I have y times this binomial. So first thing I'm going to do is change multiplication into addition. So the natural log of y plus the natural log of this binomial. Now the only thing that I can do is I can change my exponent into a coefficient now. I can't break this up further. So I'm going to take my exponent and write it as a coefficient. So the natural log of y will still stay there, plus 2 natural log of y minus 1. So again, a key concept to remember is when we solve problems like this, you never want to take things that are inside of the parentheses, that's a binomial, and pull them apart. You can break apart the multiplication of the binomial like we did to change it to addition, and then you can put the exponent as a coefficient, but never pull apart your binomial. So this would be the final answer for this problem here. Okay, in our next example here, I'm noticing that I'm taking the natural log of a radical of a square root. So remember, I'm going to change my square root sign into a exponent of 1/2. So more specifically, instead of it being x raised to the 1/2, it's going to be the natural log of the binomial a minus 1 raised to the 1/2. Okay. Again, I have a binomial. I don't want to break that binomial apart, but what I can do is change that 1/2 to a coefficient out in the front. So it'd be 1/2 times the natural log of a minus 1. This brings me up to a point that we should discuss. What if this was instead the third root of a minus 1? If you were to write the third root as a fractional exponent, it would be the power 1/3. And if it was the fourth root, it would be the power raised to 1/4. So when you're writing these roots here, you're keeping this index as the denominator. So just keep that in mind if you see another problem like that in the future. Taking a look at, so again, that's my final answer. Taking a look at the next one, what I'm noticing right away is that I have a radical that I can write as an exponent. So I'm going to change my radical to an exponent raised to the 1/2. So the natural log of x squared over y to the third raised to the 1/2. Now the next thing that I recognize is that both of these terms, the numerator and the denominator, are being raised to the 1/2. So if I'm going to change this to put it out in the front to write the exponent as a coefficient, then I want to write it as 1/2 and then a parenthesis or a bracket of the natural log of x squared over y to the third, because this 1/2 is going with both of these terms. And now I'll look at this and say this is being divided, so I can change division into subtraction. So 1/2 natural log of the numerator minus natural log of the denominator. Now that I've done that, what I'm recognizing is that I have exponents again. So I can put those exponents out in the front. So I'm going to change exponents into coefficients. So 1/2 of 2 times the natural log of x minus 3 natural log of y.